So good afternoon, everyone. I'm currently a PhD student at BSc department working under Dr. Daran Rudnick and Dr. Heeren. And my research today I'm going to share is about the nitrogen leaching problem in Nebraska. Thank you. So Nebraska has abundance of water, groundwater resource. As we can see from the map here, the groundwater withdrawal in Nebraska is at a higher level in the national wild. About 85% of residents rely on the groundwater to drink, and also groundwater is significant to the agricultural development due to the irrigation. Therefore, the groundwater is important in Nebraska, and it's important to secure the groundwater quality and quantity. However, the nitrogen leaching happen in many places in the worldwide, also including Nebraska. And from previous research, the coarse texture soil and the shallow groundwater depths could result in the nitrogen leaching problem, and excessive fertigation and irrigation water could make it worse. And therefore, the groundwater could be contaminated by the nitrogen leaching problem after the agricultural management practices. Our research is aimed to find the solutions to control the groundwater contamination by testing the innovative method. And to be more specific, in this project, we want to compare the influence of different fertigation methods with and without cover crop on the nitrate leaching. And we established two research sites in Nebraska. One is in northeast Nebraska on a grower site in Creighton, and another site is established on the UNL West Center Research Extension site in North Platte. And we had 10 treatments established at the BRD site and 8 treatments established at the second research site. And we concentrated on 4 of the treatments as I highlighted here. So we concentrate on the cover crop, include the hairy veg and winter wheat. And we also concentrated on 2 fertigation levels. First is lab-based fertigation. So the plot receives total amount of nitrogen prescribed by a commercial lab. And another is sensor-based fertigation. So the fertigation event was triggered only if the NDRE sufficiency index fall below the design threshold, which is 0.95 last year. And we sense the NDRE values every time 1 day before the fertigation event by a multispectral sensor mounted on a UAV platform. And after we receive the raw images, we put it into a software, and software provide us the different vegetation index maps. So we can use the NDRE maps to complete us, to help us complete the sufficiency index calculation. And we also developed the sampling protocols, including the deep soil sampling, soil health sampling, leaf tissue sampling, cover crop sampling, and crop biomass sampling throughout the whole growing season. And also we selected 2 types of soil moisture monitoring methods. The first type, we use the TDR sensors installed at 3 depths below ground. It could give us a continuous reading for the soil moisture. And second type is a neutron gauge. It provides us with a precise soil moisture monitoring. And last year, we had the opportunity to present our research at the ASA International Meeting in Salt Lake City, Utah. And also, we shared the technology we used to the growers on the field days in North Platte and Creighton for the TAPS program and the BGMA program. And also, I would like to share some of our interesting results. So this graph here showed our final crop yield, our total above ground biomass, and our cumulative nitrogen input. So the bars here showed the yield, and orange point here showed the total above ground nitrogen uptake, and the purple point here showed the cumulative nitrogen input. We are surprised to see the total nitrogen uptake is actually higher than the total nitrogen input. And also, even though there is about 60-pound difference between the sensor-based fertigation and lab-based fertigation, there is no significant treatment effect on our final yield. And we received similar results in another research site. The total nitrogen uptake is much higher than the total nitrogen input. And also, there's no significant treatment effect happen to the final yield. Which give us a good sign, means the sensor-based fertigation method could effectively reduce the nitrogen input while not influence the final yield and also influence the nitrogen uptake. And in next step, we want to keep develop some different research based on our research so far. So we want to focus more on the modeling part. We want to simulate the nitrogen modeling, the nitrogen leaching process by the DNDC model. And also we want to use the Duan image in the modeling process with some artificial intelligence technologies. Also, we want to investigate the different vegetation indices on the in-season nitrogen management and irrigation management. And due to the limitation of time, I probably didn't explain well, so feel free to ask any question.